Hi, kids. All right, we're going to do a little dynamics problem, Newton law problem. It says we have a 20 kilogram box. It's pushed downward, so pushing. So if you push down at 25 degrees, this says mu s. Remember, the mu is coefficient of friction. S stands for static, so the static coefficient of friction is 0.4. How much force must be exerted to get the box moving, okay? And then after that, we're going to do another problem. What would the box's acceleration be if the coefficient of kinetic friction, moving friction, is 0.2? Remember, static friction is always going to be bigger than moving friction. So first step number 1, draw your free body diagram. So if I draw my free body diagram, here is my box. And I know, it looks just like a box. Thank you very much. But there's my box. And then you're going to draw the forces acting on the box. So we have our applied force going this way. We have Fa. We have force of friction going that way. We have the normal force going this way. And then, as always, we have our force of gravity going that way. So that is our first step. If you notice, one of these vectors we have to break into its components, and that would be Fa. So if I break that into my two components, where I call this Fax for the horizontal component, and then I call this Fay for my vertical component. Okay, so step 1, boom, done. Then you have to write your two F-net equations. So we're going to say the sum of all the forces in the x direction would be, so in the x direction I have this one and this one, so it would be Fax minus Ff, and then equals, if I want it to just get moving, my Fax has to be a little bit bigger than this. So if it's a little bit smaller, it's not going to move. If they're the same size, it's not going to move. So I'm going to set them equal, and then I'm going to say, okay, well, if it's equal, as long as my force is bigger than that, then it's going to move. So there's one equation, and then my other equation is going to be the sum of all the forces in the y direction. This is x, is going to be, I have Fn minus Fg minus Fay. Okay, so again, your step 1, boom. Step 2 is use your picture to write your equation. So minus Fay, and that equals, remember, in the y side, it can never accelerate, because if it accelerates down, it's going into the ground. If it accelerates this way, then it's somehow like levitating off the ground, weird, which it can't happen. So remember, this one is always going to be 0. Okay? So step 1, step 2, boom, boom. Then it's just a matter of, now we got to plug numbers in and solve. Remember, the equation for this, okay, is Ff equals mu Fn. So if I'm going to solve for this, I first need to solve for Fn, so I'm going to use this side to solve for my Fn. So if I plug my numbers in, Fn is what I'm looking for, minus Fg. Remember, Fg is m times g. That's how you find weight. So 20 times 9.8, okay, minus Fay. Well, Fay is, if you remember, this is going to be my 25 degrees right there. Fay would be m. So sorry, Fay is going to be sine, because sine of 25 because it's opposite. So it'd be Fa times the sine of 25. Okay, and that all equals 0. If I solve here, well, then if I come over here, because I'm going to end up with kind of a little system, for this side it's going to be Fa cosine of 25 minus my mu times f of n, so minus mu Fn, and equals 0. Okay, and mu I know is 0.4. Fn is going to be this big mess. So if I take this big mess and sub it in, I'm going to end up with something that looks like this. Fa cosine 25 minus 0.4 times this whole big mess. So it's going to be times 20 times 9.8 plus, because remember, if I bring this over and this over, plus FA sine 25, and then this whole thing equals 0. Okay, then I have to do some math, and here's where I'm going to pause it. I'm going to do the calculations. You guys can do the calculations as well, and then we'll come back and solve it. Bye. Hi, all right. We're back. So I did my calculations. So cosine of 25 is 0.906. 0.4 times 20 times 9.8 is 78.4. And then 0.4 times sine of 25 is this. Hopefully you guys did your calculations as well, and you can verify this. And then I did some more math. When I get my applied force, has to be this. Now remember, my applied force has to be bigger than that. So the answer to this question is bigger than 106.3. Now, so that's the first part of the question. Now if we do the second part of our question, the only difference is going to be is this equals ma, because if I'm trying to figure my new acceleration, so I'll do it with a different color. This is going to equal ma. This is going to equal ma. Okay, where m is 20. Okay, and then when I go down here, this would be 0.2 because that's my new thing there, and my applied force is this 106. So let me change that to here. 106.3. 106.3. And then this equals 20 times A. And this is MA. Okay. The y side is still going to be the same, but and then this is not going to be 78.4. So then you got to do the math and solve for your A. I'm going to let you do the math here, so I'm not going to pause it. You can do it on your own, but you'll get some number and then meters per second squared. Remember that is your units for acceleration, and it will be pointing that way, same direction of the net force. All right, bye kids.